Hello, here we go again. So let's have another GCP Professional Architect Certification study session. Let's go straight to the point. Okay. So first of all, yesterday we got in the Silver League. We still have 6 days to stay in the top 10 and go to the Golden League. We need to accumulate points. Let's go. This is just helping us on being sure that we are having a good rhythm. We are proceeding at the right speed. So let's resume this course, which I'm completing. As I already said many times, I'm completing it just for, because I advanced until the half of it and understood that it's not really relevant for me because I will need to do all the courses here in this path. And this specific course is for people which do not want to do all the courses. So yeah, if you want to do it, it's just because one of these motivations. You just want to do everything, including this course, or you do it in order to be aware of what you need. Okay, let's go. Mm. Okay. Okay, they're repeating this stuff here. Okay. Okay, so let me see what is a microservice vs monolithic. Okay, a monolithic application is built as a single unified unit, while a microservice architecture is a collection of small independently deployable services. Which one is right for you? Service. It's infrastructure spread on top of the cloud and replace microservice architecture. The only problem was the term microservices didn't exist and the structure wasn't well known. One of the first high-profile companies that successfully migrated from a monolith to a cloud-based microservice architecture. Okay. Monolith architecture is a traditional model of a software program which is built as a unified unit that is self-contained and independent from other applications. The word monolith is often attributed to something large and glacial, which isn't far from the truth of a monolith architecture for software design. A monolith architecture is a singular large computing network with one code base that couples all of the business concerns together. To make a change to this sort of application requires updating the entire stack by accessing the code base and building and deploying an updated version of the service-side interface. This makes updates restrictive and time-consuming. Monoliths can be convenient early in a project's life for easy code management, cognitive overhead, and deployment. This allows everything in the monolith to be released at once. Advantages of a monolithic architecture. End browser, payment, shopping cart, inventory, single instance. Organization can benefit from either monolith or microservices architecture depending on a number of different factors. When developing using a monolith architecture, the primary advantage is fast development speed due to simplicity of having an application based on one code base. The advantages of a monolithic architecture include easy deployment, development, performance, simplified testing, easy debugging. Disadvantages of a monolithic architecture include slower development speed. A large monolithic application makes development more complex and slower. Scalability. You can't scale individual components. Reliability. If there's an error in any module, it could affect the entire application availability. Barrier to technology adoption. Any changes in framework or languages affect the entire application, making changes often expensive and time-consuming. Lack of flexibility. A monolith is constrained by the technology already used in the monolith. Deployment. A small change to a monolithic application requires the redeployment of the entire monolith. What are microservices? A microservice architecture, also simply known as microservice, is an architectural method that relies on a series of independently deployable services. These services have their own business logic and database with a specific goal. Updating, testing, deployment, and scaling occur within each service. Microservices decouple major business domain-specific concerns into separate, independent code bases. Microservices don't reduce complexity, but they make any complexity visible and more manageable by separating tasks into smaller processes that function independently of each other and contribute to overall whole. Adopting microservices often goes hand in hand with DevOps, since they are the basis for continuously delivered practices that allow teams to adapt quickly to user requirements. Client browser, UI microservice, payment, shopping cart, inventory. Atlassian's journeys to microservices. Atlassian followed the path of microservices in 2018 after faced growing and scaling challenges with Jira and Confluence. We found that our single-tenant monolithic architecture running on premises will not be able to scale to future needs. What? Ah, okay. Yeah, I didn't pay attention. I was on Atlassian's website, so I was saying why they're talking in first person about Atlassian. We decided to re-architect Jira and Confluence and move them to a stateful, single-tenant monolithic system to multi-tenant, stateless cloud application hosted by Amazon Web Services. Then we will decompose them over time in microservices. The project was named Vertigo after a senior engineer said, "I really like the idea, but it's giving me vertigo." It was our largest infrastructure project to date, taking 2 years to complete the transition to AWS, migrating more than 100,000 customers into just over 10 months with no service interruptions. We also committed to decomposing the services to microservices. Advantages of microservices. Microservices, it's interesting they are talking about this. Microservices are by no means a silver bullet, but they solve a number of problems for growing software and companies. Since a microservice architecture consists of units that run independently, each service can be developed, updated, deployed, and scaled without affecting the other services. Software updates can be performed more frequently, with improved reliability, uptime, and performance. We went from pushing updates once a week to 2-3 times a day. As Atlassian grows, microservices enable us to scale teams and geographic locations more reliably by splitting along lines of service ownership. Before we started Vertigo, Atlassian had 5 different development centers around the world. These distributed teams were constrained by a centralized monolith, and we needed to support them in autonomous fashion. Microservices allow us to do so. The benefits of Vertigo included increased deployment speed, disaster recovery, reduced cost, and higher performance. This allows us to get to our target faster while delivering more incremental value to customers along the way. Plus, more generally, microservices make it easier for teams to update code and accelerate release cycles with continuous integration and continuous delivery. Teams can experiment with code and roll back if something goes wrong. In short, advantages of microservices are agility, promote agile ways of working with small teams and deploy frequently, flexible scaling if a microservice reaches its load capacity, new instances of that service can rapidly be deployed, blah, blah, blah. Continuous deployment, highly maintainable and testable, independently deployable, technology flexibility, high reliability, happier teams. This is interesting. The Atlassian teams who work with microservices are a lot happier since they are more autonomous and can build and deploy themselves without waiting weeks for a pull request to be approved. And this could be frustrating, having the ability to go in a meeting, decide what has to be done, do it, while ideas are fresh. It's a great advantage. I found myself in the situation of having the meetings with my team, especially business part of the team, deciding something. Myself, I was proposing some cool ideas, things I really thought they were good for the business. I was receiving an approval to proceed with that, and then I had to hit myself with uh, all the bureaucracy, all the difficulties in, just implementing the solutions, integrating them, and deploying them. Sometimes in some recent companies where I had to work, it took me months to just deploy a simple tool, which was just crude. I could not proceed. I was receiving bad feedback from my managers because I wasn't delivering. And at the same time, I wasn't receiving support to push because, all the team was concerned about this giant monolithic application where I could not integrate myself with freedom. Let's say I had to learn a lot of useless new stuff from which I was depending, and in which I had to integrate my new software. So I wasn't able to deliver value as fast as my ideas were working. Yeah, it was a stressful situation. It can affect also the psychological um, layer of new employees. I was a new employee in this company, and I was starting to doubt myself of my capacity to deliver value, as I wasn't able to get part to the building of this company's software. So at the end, I had to split from them because it was a toxic situation. They were not ready to integrate new people. They weren't able. They weren't in a position where it was easy to do. So I understand them. I'm not blaming anybody, but I'm just analyzing the situation, and it's a really bad situation to get in a giant corporation where they have this giant application which moves all together really slowly. Where it's a nightmare. So I'm happy that I've learned about these terms. Of course, yeah, there are some disadvantages for microservices too. Yeah, of course, it costs a lot because you will basically have many tools, as many services you want to deploy. Organizational overhead, okay, debugging challenges. Each microservice has its own set of logs, which makes debugging more complicated, plus a single business process can run across multiple machines, further complicating debugging. Lack of standardization. Without a common platform, there can be a proliferation of languages, logging standards, and monitoring. Lack of clear ownership. So map out a migration strategy, tooling, manage expectation, embrace a culture shift, balance speed and trust. Yeah, let's go. Chaos Monkey. Wow. Chaos engineering. Chaos Monkey. Chaos Monkey randomly terminates virtual machine instances and containers that run inside of your production environment, exposing engineers to failures more frequently and incentivizes them to build resilient services. For info on how to use Chaos Monkey is an example that follows principle of chaos engineering. Chaos engineering is the discipline of experimenting on a system in order to build confidence in the system capability to withstand turbulent conditions in production. Advances in large-scale distributed software systems are changing the game for software engineering. As an industry, we are quick to adopt practices that increase flexibility of development and velocity of deployment. An urgent question follows on the heels of these benefits: how much confidence we can have in a complex system that we put into production. Even when all of the individual services are in a distributed system are functioning properly, the interactions between those services can cause unpredictable outcomes. Unpredictable outcomes compounded by rare but disruptive real-world events that affect production environment make this distributed system inherently chaotic. We need to identify weaknesses before they manifest in system-wide aberrant behaviors. Systemic weaknesses could take the form of improper fallback settings when a service is unavailable, retry storms from improperly tuned timeouts, outages when a downstream dependency receives too much traffic, cascading failures when a single point of failure crashes. We must address the most significant weaknesses proactively before they affect our customer in production. We need a way to manage the chaos inherent in these systems, take advantage of increasing flexibility and velocity, and have confidence in our production deployments despite the complexity that they represent. Chaos in practice. Start by defining a steady state as some measurable output of a system that indicates normal behavior. Hypothesize that this steady state will continue in both the control group and the experimental group. Introduce variables that reflect real-world events like servers that crash, hard drives that malfunction, network connections that are severed. Try to disprove the hypothesis by looking for a difference in steady state between the control group and the experimental group. Okay. I will say that Bitcoin is a really great example of chaos engineering. Bitcoin. A critical component of any blockchain or distributed ledger technology platform is the consensus algorithm. Blockchain consensus algorithms are the primary vehicle for nodes with blockchain network to reach an agreement. In recent years, many blockchain consensus algorithms have been proposed mainly for private and permissioned blockchain networks. However, the performance of these algorithms and their reliability in hostile environment or the presence of Byzantine and other network failures are not well understood. In addition, the testing and validation of blockchain applications come with many technology challenges. In this paper, we apply chaos engineering testing to understand the performance of consensus and algorithms in the presence of different loads. Okay, but on which I have to sign in. I mean, I don't want to put time in this moment, but yeah, I had this idea. So I'm really interested in Bitcoin, not in blockchain, because blockchain is just a clickbait. Bitcoin is the only one. It's the only real blockchain, so it doesn't make sense to have another term. Let's just say Bitcoin. It's the only real decentralized network. I mean, and it's also weakly decentralized, I will say, but it's the only one. But this is a topic for other videos. I have a series of videos about developing for Bitcoin Core. So yeah, these are a lot of interesting topics, but let's go to the practice. Okay, diagnostic questions. We have 10 questions here. You want to establish procedures for testing the resilience of the delivery by drone solution. How would you simulate a scalability issue? Block access, inject a bad health check, block access to storage, load test your application to see how it responds. You are asked to implement a lift and shift operation or simple direct social media highlighting service. You compose a Terraform configuration file to build all the necessary Google Cloud resources. What is the next step in Terraform workflow for this effort? Run Terraform apply to deploy the resources described in the configuration file. Write Terraform plan to verify the content of the Terraform configuration file. Commit the configuration file to your software repository. Run Terraform init to download the necessary provider modules. I have no idea. So Terraform plan. The Terraform plan command creates an execution plan which lets you preview the changes that Terraform plan to make your infrastructure. Okay. Init, Terraform init. Terraform init command initializes a working directory containing Terraform configuration files. This is the first command that should be run after writing a new Terraform configuration or cloning an existing one from version control. Okay, so you compose a Terraform configuration. Okay, this is the first. The pilot subsystem in your delivery by drone service is critical to your service. You want to ensure that connections the pilot subsystem to the pilots can survive a VM outage without affecting connectivity. What should you do? Deploy a load balancer to distribute traffic across multiple machines. Configure proper startup scripts for your VMs. Create persistent disk snapshots. Implement a managed instance group and the load balancer. The number of requests received by your application is nearing the maximum specified in your design. You want to limit the number of incoming requests until the system can handle the workload. What design pattern does this situation describe? Applying graceful degradation, exponential backoff, so you want to limit the number of incoming requests until the system can handle the workload. I'm not sure if it's exponential backoff. Exponential backoff, maybe. Yeah, because you start with like a new cluster of machines which will be able to handle the workload, if I'm not sure. Exponential backoff. Exponential backoff involves increasing the delay between retry attempts exponentially. So this is graceful degradation. Why specific behaviors may be difficult to predict? They can plan for macro level issues such as saturation, long latency, and excessive workload. Part of that planning should include designing of graceful degradation of services, which allows for more limited functionality while avoiding catastrophic failure. Network engineers, for example, design networks to reroute traffic if a path is no longer available. This may lead to higher saturation of other routes and longer latencies, but the traffic eventually reaches its destination. Large-scale enterprise applications can similarly benefit from designing for graceful degradation. When designing your system consider which of the established practices work best for your service, starting from the most lasting powerful this. Okay, graceful degradation. Symbol Direct wants to improve its drone pilot interface. You want to collect feedback on proposed changes from the community of pilots before rolling out updates system-wide. What type of deployment pattern should you implement? You should implement a blue-green deployment, implement A/B testing. Your development team used cloud source repositories, Cloud Build, and Artifact Registry to successfully implement the build portion of an application CI/CD process. However, the deployment process is erroring out. Initial troubleshooting shows that the runtime environment does not have access to the build images. You need to advise the team on how to resolve the issue. What could cause the problem? The artifact registry might be in a different project. The runtime environment does not have permission to cloud source repositories in your current project. The runtime environment does not have permission to the artifact registry in your current project. You need to specify the artifact registry image by name. So I will say it's permissions issue, and the runtime will take things from the artifact registry, not from cloud source repositories. In the repositories, you put the code, which then will be built, and the build will be saved to the artifact registry. And yeah, it's more probably it's a permission issue. The runtime environment does not have permissions to the artifact registry in your current project, or maybe in a different project. I mean, it's, yeah, I will say permissions as it's just a frequent issue. You are implementing a disaster recovery plan for the cloud version of your drone solution. Sending videos to the pilots is crucial from an operational perspective. What design pattern should you choose for this part of your architecture? Hot with high recovery time objective. I have no idea. So disaster recovery plan, hot, warm, cold. What the fuck is this? Okay, so iCorp says cold computing sites, the most simplistic type of disaster recovery site. A cold site consists of elements providing power, networking capability, and cooling. It does not include other hardware elements such as servers or storage. Using a cold site is very limiting to a business since before it can be used, backup data and some additional hardware must be sent to the site and installed. Warm computing sites contain all elements of a cold site while adding additional elements include storage hardware such as tape or disk drive, servers, and switches. Warm sites are ready to go in one sense, but they still need to have data transported for use in recovery should a disaster occur. Hot computing sites, a fully functional backup site that already has important data mirrored in. This is the ideal disaster recovery site, but it can be challenging to attain. Ensuring access to application and data following a disaster is just one piece of success. Planning should assess your own planning efforts to analyze your. Okay, so we have to understand the videos. Where are they at this level? So cold, of course, warm. I will say hot because this way they already have everything. They just need to switch in the moment something is happening. With a low recovery time objective. Recovery time objective is the maximum amount of time that is acceptable for restoring and regain access to data after disruption. I mean, it has to be instant, not just low. You have an application implemented on Compute Engine. you have an application implemented on Compute Engine. You want to increase the durability of your application. What should you do? Implement a scheduled snapshot on your Compute Engine instances. What does mean durability of an application? I mean, perform health checks, monitor your application usage metrics, implement autoscaling, implement a regional managed instance group. I will go with this. It's a managed solution, which is one of our business requirements, technical requirements, also business. Monitor application usage metrics and implement autoscaling. I mean, the durability, implement a regional managed instance group. Yeah, the regional stuff is again something. But it's about the application data. Health check will allow for preventing Compute Engine failures. Application user metrics also looks like implement a scheduled snapshot, implementing a regional managed instance. I'm more prone for this. Developers on your team frequently write new versions of the code for one of your applications. You want to automate the build process when updates are pushed to the cloud source repositories. What should you do? Implement a build trigger that references your repository and branch. Implement a cloud build configuration file with build steps. Set proper permissions for cloud build to access deployment resources. Upload application build process. It's just the build and not the deployment. So set proper permission to access deployment? No. Upload application updates and cloud build configuration files to cloud source repositories. Implement a cloud build configuration file with build steps. When updates are pushed, I need a trigger. You have implemented a manual CI/CD process for the container services required for the next implementation of Simba Direct's drone delivery project. You want to automate the process. Configure and push a manifest file into an environment repository in cloud source repositories. Implement a build trigger that applies your build configuration when a new software update is committed to cloud source repositories. Implement a reference a source repository in your cloud build configuration file. Specify the name of your container registry in your cloud build configuration. Again, I would say a trigger is lesser. Let's see. Oh, fuck me. So you want to establish procedure for testing resilience. How would you simulate a scalability issue? Load test. For the scalability issue, load test. You are asked to lift and shift. Okay, so after you compose a Terraform configuration file, the first one is the Terraform init. You want to ensure the connection of the pipe can survive a VM outage. Okay, implement a managed instance. The number of requests received is nearing the maximum, increasing jitter. You want to limit the number of incoming requests until the system can handle workload. They will retry. Maybe it's exponential. Graceful degradation leaves the results provided by the system when certain thresholds are met. It does not limit or respond with error-based or new or additional requests. Okay, so exponential backoff looks like better. It gives more time, and more time until the system can get pace again. Okay, so A/B testing for different community of pilots. So this is the first error, and I will need to put exponential backoff. This one, you want to. Your development team, blah blah blah. What could cause this problem? You need to advise the team on how to resolve the issue. Okay, so it wasn't the permissions. The deployment process is erroring out. So the artifact registry may be in a different project. Maybe by name. We'll try this one. You are implementing a disaster recovery plan. Okay, this one was okay. You have an application implemented in Compute Engine. So while managed instance group can indirectly contribute to durability by minimizing downtime and maintaining service continuity, the primary increase availability, and I need durability. So I will go for the snapshots. Cloud build triggers automate the build process when new files are placed into the name and branch of the repository that you specify. Okay, I will retake it. Let's see. You want to increase durability, so I will go for snapshots, as all of the others will increase the availability. The number of requests, you want to limit the number of incoming requests, exponential backoff. Your development team, however, deployment is running. Okay, you need to advise the team. Okay. So if I'm receiving errors and it wasn't permission, I put this one before. Maybe it's this one. You want to establish procedure for testing resilience, load test. You are asked to implement a lift and shift, init, new version of the code. You want to automate build, update, so it will need a trigger. The pilot subsystem, you want to ensure that connection will survive. What should you do? I don't remember. So I did wrong this one. is critical to your service. You want to ensure that the connections to the pilots can survive VM outage affecting connectivity. Instance growth load balancer. You have implemented a manual CI/CD. You want to automate the process. Implement a build trigger. Hot with a low recovery time. Symbol Direct wants to improve its what type of deployment pattern should you implement? A/B testing. Oof, I did wrong against something. Oh, not graceful degradation, it's not exponential backoff. Exponential backoff increases the amount of time between retries, it does not limit them. So applying increasing jitter, okay. Okay, try behavior. So after it is continues to serve as a pillar for another remote client reverse. They don't support experience jitter as part of retry behavior when using standard adaptive modes. Consider this part and leverage without having incorporate personal logic. Okay. Optimistic concurrency control. Blah blah blah. Jittering. Some back off. Adding jitter. The solution isn't to remove back off. It's to add jitter. It may appear to a counterintuitive trying to improve the performance of the system by adding randomness. The time series above make a grid from jitter. We want to spread out spikes and program a constant rate. Adding jitter is a small change to the sleep function. Reduce our call count by more than half, improve the time. Okay. Oh, see. So jittering like is spreading the calls. And then again, in that fact, I did wrong this one. You need to identify me by tag or digest. So artifact registry images by name, no. Runtime environment does not have permission to have no. Maybe, I mean, it's one of these two, but I have to understand it. You want to okay. Let's go forward. And okay. Yeah, of course. Thank you. And as always, I do not expect something new here. This PDF advises me which content to choose if I did wrong the questions, and in reality I took note of all these courses here. I already have them all, and they are always advising the same courses. I mean, with reference to different modules. But yeah, I will take them all. Yeah, it's just all the same stuff. And let's go knowledge check. Symbol Direct needs a database for their next project. They want to meet their business and technical objectives. What should they do? Use a managed database service. Symbol Direct has decided to use cloud build with technical requirements which technical requirements justify this decision. Let partners secure allow for stream of ensure developers can deploy container based on workloads. Great. So I will do some extra content in this session. Normally I do just a module. In this case, I will do everything together. Okay. Really interesting module, this one. Mm-hmm. Okay, I took time to read all these details because it's interesting. I think I know nothing about these aspects. I will go kind of fast in this case because I already understand that I have a poor knowledge. So I will not try to invest too much time. I do not expect to get really good score here. Symbol Direct releases new version of its drone delivery software. 1.5 2 months old. All the most releases are successful. You have experienced 3 programmatic releases that made drone delivery unavailable with software developers rolled back to release. You want to increase the reliability of software releases and prevent similar problems in the future. So yeah, I would avoid waterfall. Okay, maintaining the current release schedule, automate building process from a source repository, automate testing after the build process, use cloud monitoring, cloud logging, cloud alerting to ensure visibility, deploy the previous version if problems are detected and you need to roll back. Canary deployment sounds like the thing I would use. Canary deployment is a parsec rollout application that splits traffic between, yeah, okay. So this is the right one. So you basically test the new version of the software with a small cohort of users and then progressively expand the cohort that receives the new software version. You need to adopt site reliability engineering principles. Reliability engineering principles and increase visibility into your environment. You want to minimize management overhead and reduce noise generated by information being collected. You also want to streamline the process of reacting to analyzing and improving your environment, and to ensure that only trusted containers images are deployed to production. Okay, so Google Cloud Observability looks like present in all the options. There's a bit of marketing here. Use Cloud Trace for distributed tracing, Cloud Logging for logging, monitoring for monitoring. Okay. Page the on-call contact. Hey, wait for a second. So page the on-call contact when issues that affect resources in the environment are detected. Page the on-call contact when issues that affect resources in the environment are detected. Only page the on-call contact about novel issues or events. Only page the on-call contact about novel issues that violate a service level objective. What the fuck? Why Spanish? The overall agreements between providers, while the seller actual promises that service made to clients. Okay. So only page the on-call contact. Mm. I would say binary authorization. And on-call contact, I mean, the difference is if to page the on-call contact when issues that affect resources in environment are detected. Only page slower than been seen before. This sincerely looks like better. GPG, I think it's kind of costly. Binary authorization maybe has some advantage. Binary authorization. There's also special secure application around. It looks like restricted to JKE. And in this case, maybe we will need to use GPG. Okay. Domingo, are you tired? Do you need a break? 5 minutes, 10 minutes more, and I will be finished with this. Symbol Direct's warehouse and inventory system was written in Java. The system uses a microservice architecture in JKE and instrumented with Zipkin. Similarly, at random, a request will be 5-10 times slower than others. The development team tried to reproduce the problem in testing, but failed to determine the cause of issue. System user microservice architecture. Request. Also, there's an intermittent issue of requests which have a peak time. What should you do? So create metrics in cloud monitoring for microservices to test whether intermittent or slow down to respond to HTTP requests. Use cloud profile to determine which function method in your application code use most system resources. Use cloud trace to identify slow requests and determine which microservice calls take most time to respond. This error reporting to test whether microservice will slow respond. No, I wouldn't use anything related to errors because we are not having errors. Cloud profiler to know which functions, cloud trace, which function. I think that cloud profiler sounds like more a software which will tell me cloud trace provides latency sampling and reporting for App Engine, including variable statistics. Cloud profiler will continuous profiler resource consumption. Yeah, it will tell me more relevant information. So this is the right order because in this case they basically crossed. Come here, help me instead of crying. Please take a seat with me. Come with me. Oh, yes. So I think you already know Domingo from other videos. He's my assistant. Sometimes he cries, and yeah, he just needs to participate to the process, right? Please. Okay, take position. Let's go. Let's see. Domingo, your client has adopted a multi-cloud strategy that uses a virtual machine-based infrastructure. Hope people can still hear me. The client's that uses a virtual machine-based infrastructure. Okay, the client's website servers use users across the globe. Serves users across the globe. Okay. The client needs a single dashboard view to monitor performance in their AWS and GCP environments. Your client previously experienced an extended outage and wants to establish a monthly service level objective of no outage longer than an hour. What should you do? Okay, so your client previously experienced it. Wow, there's a lot of business language here. In cloud monitoring, create an uptime check for URL your clients will access. Configure it to check for multiple regions. Wow. View motors. Okay, so I see that I will need to integrate data from AWS also. Create a new project to use as an AWS connector project. Authorize access to the project from AWS with a service account. Install the monitoring agent and computer engine instances. Use cloud monitoring to create dashboards that use the performance metric for virtual machines to ensure that the SLO is met. Use cloud monitoring to create dashboards. Okay. So authorize access to Google Cloud Project from AWS with a service account. Hey, please concentrate on the task. In cloud monitoring, create an uptime check for the URL clients. Configure to check for multiple regions. Use cloud monitoring dashboard to submit. Okay. Authorize access to your Google Cloud project from AWS with a service account. Install monitoring agent and computer. Use cloud monitoring to create dashboard. Okay, I think it's this one because authorize access to the project from AWS with a service account. Okay, this makes sense a bit more. Your organization is planning a disaster recovery strategy. Your stakeholders require a recovery time objective of 0 and a recovery point objective of 0 for zone outage. They require an RTO of 4 hours and RPO of 1 hour for a regional outage. Your application consists of a web application and a backend MySQL database. You need the most efficient solution to meet your recovery KPIs. So please, Domingo, let me concentrate on these last questions. I will let you go wherever you want. Oh, please feel free to go around the house, drink some water. Thank you. Your organization is planning a disaster recovery strategy. So your stakeholders require a recovery time objective of 0 and the recovery time point objective of 0 for zone outage. So RTO and RPO 0 for zone outage. They require an RTO of 4 hours and RPO of 1 hour for regional outage. So this is kind of less probable. This is why they accept for a less probable scenario, less slower recovery. Your application consists of a web application and backend MySQL database. You need the most efficient solution to meet your recovery KPIs. What should you do? Okay, so here we have a global HTTPS load balancer in all the options. Deploy the web application as compute engine managed instance group in 2 regions, US West and US East. Configure the load balancer to use both backends. Okay. Configure load balancer to the US East backend, use Cloud SQL with high availability. Enabled in US East and cross-region replica in US West. Use Cloud US East and backup is every hour to multi-region cloud storage packet. Basically, if there's a failure, manually promote the user. And manually is not good. I mean, my intuition says we should not do manual stuff. I mean, depends of how much time we have, but recovery time objective and recovery point objective. There's this detail about enabling US and backup the database every hour to multi-region cloud storage bucket. I will say that this is okay as changing region. To change region, we have 4 hours. I'm not sure about what this means. Recovery point objective. 0 and 1. But yeah, I will go cross-region replica instead of cloud storage bucket. What does mean having a cross-region replica? There are two common scenarios for promoting cross-region replica: regional migration, disaster recovery. Both involve setting up cross-region replication and promoting development. The main difference between them is whether the promotion of the replica is planned. In the case of regional migration, or unplanned failover. Disaster recovery. Cross-region replica can be used as part of a disaster recovery procedure. You can promote a cross-replica to fail in a region should the prime minister in the region become unavailable for an extended period of time. If you're using Cloud SQL, then you can design a cross-region RED replica as a disaster recovery replica for advanced disaster recovery. With advanced disaster recovery, you perform replica failover to replace the old prime minister becomes a replica of the promoter. You can only perform replica failover to the designated. You can say, okay, to return your deployment to the region state after replica failover, you can perform a switchover. Since the old prime minister is a replica of the new prime minister, you can switch roles again to restore the old prime ministers. Okay, so recovery point objective in case of regional outage is 1 hour. So it will be okay to have I mean, this can be interpreted as how many transactions can we lose in case of regional outage. In this case, it's saying last hour outage. Okay, so this allows us to basically rely on a cloud bucket multi-region cloud storage. Okay. Hmm. Wait a second. So we have always the HTTPS load balancer, deploy application instance group into regions. Okay. Okay. Configure load balancer to use both backends. So change the load balancer backend to US West. For me, doesn't make sense. Manually promote, no. Never use it. Oh, register. Maybe. Yeah, so the use cross-region replica. I will try with this one. Symbol Diary has a new social media integration service that pulls images of its product from social media sites and displays them in a gallery of custom images on your online store. You receive an alert from Cloud Monitoring at 3 a.m. on Saturday. The store is still online, but the gallery does not appear. The CPU utilization is 30% higher than expected on the VM running the service, which causes the managed instances group to scale to the maximum number of instances. You verify that the issue is really by checking the site, and verify that it's not CPU related by checking the incident timeline. What should you do to resolve the issue? CPU utilization is higher than expected. Verify that it's real and by checking the incident timeline. What does mean this statement? Check the incident documentation or labels to determine the on-call contact. Appoint an incident commander and open a chat channel or conference call for emergency response. Investigate and resolve the issue by increasing the maximum number of instances in the MIG and verify that this resolved the issue. Mark the accident as closed. What? Investigate and resolve the issue by increasing. Increase the maximum number of instances in the MIG and verify that this is check the incident documentation labels and on-call contact. So cloud monitoring, receive an alert. Okay, this is kind of messy. Simple Direct is working on a social media integration service in Google Cloud. Mahesh is a non-technical manager who wants to ensure that the project doesn't exceed the budget and responds quickly to expected cost increases. He needs to set up access and billing for the project. What should we do? Use predefined billing account administrator role for the billing administrator group. Group. Create a project budget. Configure billing alerts to be sent to the billing account administrator. Use resource quotas to cap how much money can be spent. Saying the predefined billing accounts or create a project budget. Configure billing alerts to be sent to the project owner. Assign the predefined billing account administrator or create a project budget. Configure billing alerts to be sent to billing administrator. I'm choosing this just for coherence because I want to configure this to be sent to the group, which is called billing administrator. In this case, the role is called like this. the group is called like this, and the notifications are sent, the alerts are sent to the role, which I'm not sure that can be used as target for the alerts. I think that the group can be used for the alerts. Your environment has multiple projects used for the development and testing. Each project has a budget, and each developer has a budget. A personal budget overrun can cause a project budget overrun. Several developers are creating resources for testing as part of the CI/CD pipeline, but are not deleting these resources after they test and complete. If the compute resource fails during testing, the test can be run again. If you want to reduce cost and notify developer when a personal budget overrun causes a project budget overrun, what should you do? Go to BigQuery. Create a Google Cloud. Okay, so it's already create a Google budget for each project. Okay, create a group for developers in each project and add them to the appropriate group. Create a notification channel for each group. Configure a billing alert to notify the group when their budget is exceeded. Modify the build scripts pipeline to label all resources with label creator so the developer's email address. Use spot preemptible instances wherever possible. So I will exclude this as I'm not sure I can delete anything like just as default action. All have the preemptible instances. In this case, we are using a group notification channel for each group and bill alert to the group and a labeling script. Labeling script also here. Okay. So the real difference is if using pub subtopic, developer budget notification, or the grouping system. Okay, so in this case, we are having basically a notification directly to the guy for the developer budget notification. Create a Google Cloud budget for each project. Create a pub subtopic for developer budget notifications. Create a cloud function to notify developers and labels. This looks interesting. Create a based on labels. Okay. No, I don't care about billing admins. I want to tell to the guy that his budget is finishing. This is incoherent. So here we are mailing a specific guy, billing alert to notify a group when their budget exceeded. But we are talking about personal budgets, so I will go with this one. Symbol Direct uses a proprietary service to manage on-call rotation and alerting. The on-call rotation service has an API for integration. Symbol Direct wants to monitor its environment for service availability and ensure that the correct person is notified. The on-call rotation service has an API for integration. Okay. So they have their service exposed with an API. So with this service, I can understand who's on call, who I have to alert. Ensure that VPC firewall rules allow access from the IP addresses used by Google Cloud's Uptime Track service. Ensure that VPC firewall. Fuck, there's always this firewall. But service to proprietary service to manage on-call rotation and alerting. Rotation service has an API. What? Add the URL for the on-call rotation API. Man, this is fucked. There's a lot of information. I'm tired. I will just throw it. Ah, fuck this. I made them all wrong. So this video will close here. I will try this again later. I'm kind of tired, and this looks more complex than I was anticipating. So